Binomial distributions meet the following 4 criteria, which can be memorized through the acronym BIDS. Binary, or in other words, that there's only 2 possible outcomes, such as passing or failing a test, or flipping a coin. Independent trials, meaning that outcomes of different trials do not affect each other. Defined number of trials, meaning that the total number of trials is known beforehand. And finally, same probability for all trials. So if you draw 3 cards from a card deck wanting to get the ace of heart, this is actually not an example of a binomial distribution, because each card you draw affects the probability of each of the remaining cards that you draw. Throwing a die, on the other hand, 3 times, wanting to get 6 on all 3 throws, that is an example of a binomial distribution, because the probabilities remain fixed between trials. For perhaps some more relevant examples to your students out there, let's imagine that you take a multiple choice test that has 4 answer alternatives with 1 correct answer for each question and a total of 10 questions. What is the probability that you barely get a passing grade? In other words, what are the chances that you answer exactly 5 questions correct, while you just answer questions at random? To calculate this, we use the quite nasty looking binomial formula. Px equals n choose x times p to the power of x times q to the power of n minus x, where n is the total number of trials, in this case 10, x is the number of successful events we are looking for, in this case 5, p is the probability of a successful event, in this case 0.25, and q is the probability of an unsuccessful event, in this case 0.75. But don't worry, this formula looks much worse than it actually is. Let's start with n choose x. This gives us the total amount of combination in which we can answer exactly 5 questions correctly. Since there is a total of 10 questions, we could answer the 5 first ones correctly, or we could answer the 5 final questions correctly, or then anything in between. This part of the formula lets us count all of these possible alternatives. So 10 choose 5 is written out as 10 exclamation mark divided by 10 minus 5 exclamation mark times 5 exclamation mark. In case you are not familiar with exclamation marks in your equations, it's just a factorial and it is quite simple to use. So in this example, 10 exclamation mark is the same as 10 times 9 times 8 times 7 and so on, all the way to times 1. This means that we can simplify the equation further like so. Don't worry, this was the hardest part. Now we can plug in this number along with the others into the formula to get 252 times 0.25 to the power of 5 times 0.75 to the power of 10 minus 5 or 5. So this part gives us the total amount of possible outcomes. This part gives us the probability of exactly 5 successes and 5 failures. So when we plug in the numbers, we get 0.0584 or 5.84%. Now, if you want to calculate the mean and standard deviation, the formula for those are mean equals n times p, which is just 10 times 0.25, and the standard deviation equals the square root of n times p times q. So when we plug in the numbers from this example, we find that the mean in this case is 2.5 and the standard deviation is 1.369. If you want to learn more about statistics, check out this playlist.